Hey all you cool cats and kittens, Carole Baskin here. Gonna show you how to do some probability with and or. Maybe later I'll teach you how to feed a tiger. So, hopefully you have your notes all printed out. If not, you can just follow along on a piece of paper. All right, take a look at that. It's amazing, isn't it? Okay, so, wrong page. La, 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 la. Sorry about that. Here we go. Okay, so we've been doing two-way tables the last few days. We did or on the first day, and then yesterday you did and today we're going to sprinkle in something new called conditional. But before we get to the questions, we got to finish this two-way table. All right, so looking at the total for T, we have 20 people who want T when they're studying. So that would be 18. I think I would be in the T category. Yes. All right, coffee. If you add that up, that totals to 35. Over here, we have to fill in some blanks. All right, let's go across the row, right? Going across the top there. We have a total of 56. So 56 minus 15 minus 2. That leaves us with 39 for right there. Okay, now I can do the energy drink total for that column. So 6 plus 39 is 45. Alrighty, I can go across this way now. So we have 18 people that want tea, 20, and this is females that want coffee, and 6 that want an energy drink. So there's 44 total females and 56 total males. When you add that up, you get 100. Oh, so the grand total is 100. All right, so here we go. And this is when both statements have to be true. This is restrictive, right? Because both statements have to be true. You can also consider this the overlap, right? So you're looking for the overlap, and it's always out of the total. So this 100 is going to be our denominator when we're doing this column of work. When we see the or statement, or means add. All right, so I'll put a bunch of plus signs there. Add, 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 add. All right, so the formula for this one, when you have the probability of event A or event B, you take the probability of A and you add it, because that's what the or means, to B. But after you add it, you have to watch out, because you might have an overlap that you have to subtract. If there is no overlap, then you don't have to sweat it. But if there is, watch out and make sure you subtract that over counting. The new stuff, conditional. This is when you consider only a given group, which changes your denominator. So whatever is given is now your denominator. Instead of being the grand total, right? These all use totals. Total. So 100 is the denominator in all those fractions. But when it's conditional, it's the given that's going to go under here. So you're going to look for keywords like given. You might look for keywords like if. All right, and I'll show you what that looks like in a minute. All right, so let's take a look at this the second row. What is the probability of randomly choosing a male and a student who prefers coffee? So we're looking for the overlap. So male and wants coffee. So male and wants coffee. There's 15, right? There's 15 men that want coffee out of 100. 15 out of 100, and that's it. All right, so let's try the next one. What is the probability of randomly choosing a male or a student who prefers coffee? Okay, so this one I'm gonna be a little bit more fancy on just so you can follow the formula with it. Probability of male or prefers coffee. All right, so the first thing we need is males. How many males are there? We've got 56, and I'll circle that up. All right, so 56 guys. The word or means add. So now we're going to look up coffee. So who wants coffee? Me. Coffee. So 35 people want coffee. But when we do the addition with or, we tend to overcount, right? Here or there. More with or, we gotta fix that. So we're gonna subtract off what we see twice. 15 got circled twice. So we'll subtract the overlap of 15 over 100. When you're dealing with fractions, if the denominators are all the same, you just have to run through the numerator then. So when you're typing it in, it might save some time instead of hitting the fraction button. Okay, so you've got 56 plus 35 minus 15. So that's 76 out of 100. You can reduce it. You can turn it into a decimal. You can make it a percent. You do you, boo. You do you, boo. All right. Except Joe Exotic. All right. Here's the new. All right, so you haven't seen this yet. What is the probability of a student who prefers coffee given that a male is chosen? So instead of being out of 100, we're going to ignore the females and focus only on the males. So my denominator is now 56. All right, so again, watch for those keywords like given. So that's going to be our new denominator now, 56. All right, so out of those 56 males, who prefers coffee? 15. 15 prefer coffee. So 15 out of 56. It looks very similar to the and, doesn't it? Yeah, so the difference is our denominator. So you have to watch out. You have to read very carefully. If they're asking you to narrow it down using the word given or if, something along those lines, then it changes. But if it's a straight up and problem, leave that denominator the grand total. All right, let's try a couple more. What is the probability of randomly selecting a female who prefers tea? All right, so this is the probability of female and wanting tea. All right, notice they didn't come out and say the word and. All right, so you just have to think it through. Probability of female and preferring tea. Okay, so female and preferring tea, there's 18 of them. So 18 ladies out of 100. All right. What is the probability of randomly choosing a female or a student who prefers tea? So female or tea. All right. So female, we have 44 females. So 44 out of 100. The word or means add. How many people want tea? Tea. 20. 20 people like tea. And then we subtract the overlap. I didn't do the circles on this one. You can circle it yourself if you want to, but we're looking at tea and females. All right, so tea and females, 18 is the number that's getting hit twice. All right, so 18 is the overlap. Okay, so we've got 44 plus 20 minus 18, which is 46 out of 100. Yeah, lovely. Okay, and then the last one, what is the probability of females choosing tea? Okay, so they're telling us to only focus on females. All right, probability of females choosing tea. All right, so if we're only looking at females, that is 44. Alrighty, and who wants tea? There's 18 of them. All right. So what's the difference? Let's see, they're telling you we're only focusing on females choosing the tea. Whereas over here, gosh, they're so similar. What is the probability of randomly selecting a female who prefers tea? What is the probability of females choosing tea? Got it. So this one is narrowing you down only to females. Okay, it's a little confusing. We'll get our practice going though, so you can start to see the little differences that will be popping up. So you've got a page to do for yourself. This one is the Titanic data. So it's almost all filled out. You need to get your totals, and then you'll go through and you'll do your ands, your ors, and these conditionals. Alrighty, I kind of want to help you out on this last one before I let you go. What is the probability of being a third-class passenger if, there we go, so there's a keyword, if you survive the Titanic. So your denominator is going to be survived. Survived. All right, so you'll look for your total of survived for that bottom. And then what is the probability of a passenger who survives given? All right, so given and if, that's what goes on your bottom. So given she was from first class. All right, so you would get your first class total here. And then count up how many survives out of first class. Okay, all right, so give it a go. I'll put the answer key on the blog so you can check yourself. Snap a picture and send it to me on Edmodo so you can get your credit for today. And I sure do miss you guys. Hope you're doing okay. Toodles.